Hi all, this is Manohar Reddy, Assistant Professor, Department of Cybersecurity, Institute of Aeronautical Engineering. So today I am going to discuss about the topic Chinese Remainder Theorem. So Chinese Remainder Theorem. So the name itself, Remainder Theorem. So we'll find out the modulus of the values. We'll find out the modulus of any numbers. So the reminders you are going to know about. So Chinese Remainder Theorem. So here you can see if you want to state that Chinese Remainder Theorem. So if M1, M2, M3 up to Mk. So if M1, M2, M3, M4, M5 up to Mk are pairwisely relatively prime positive integers. The name itself will see pairwisely relatively prime positive integers. And if A1, A2 up to AK are any integers, then the simultaneous congruences. Congruences are nothing but relatives of these numbers, relatively primes. So you can say that. So the solutions are x congruents to A1 of mod M1, x congruents to A2 of mod M2, up to x equals x congruents to AK of mod Mk. So this symbol indicates congruent. This symbol indicates congruence. If you write like this is a assignment, so that is nothing but equals to, so assigning the value. So here congruents to that are relatively, this x is a relatively to this A2 of mod M2 value, x is relatively A1 of mod M1 value, and x is relatively AK of mod Mk value. Have a solution. And the solution is unit modulo of M. So where M equals to M1, M2, up to M1 into M2 into M3 into up to Mk. So these are all M positive integers that have a unique solution. So this is the way you can state that Chinese remainder theorem. So if you take M1, M2 up to Mn or Mk are pairwisely primely relatively numbers, pairwisely prime positive integers. So if A1, A2 up to AK are any integers, then you can say that the simultaneous congruences having the unique solution, that solution is unique modulo M, where M equals to M1, M2 up to Mk, M1 into M2 into M3 into Mk, right? So we need to find the solutions of that simultaneous congruences. So the simultaneous congruences having x equals to some value, x equals to some value. So then we'll find out that unique solution for that all the simultaneous congruences, right? So how we are going to show here. So proof of this solution exists. To keep this notation simpler, we will assume k equals to 4. So k equals to 4 means you can write up to x equals to A1 mod M1, x equals to A2 mod M2, x equals to A3 mod M3, x equals to A4 mod M4. So you can write up to 4 positive integers. So note that proof is to be constructive. That means we are going to construct the table and the solution. We are going to construct the table and solution. So as how to actually construct a solution. So our simultaneous congruences are what? X equals to A1 of mod M1, x equals to A2 of mod M2. This is not equal, this is congruence. You can say that congruence. If you are not able to pronounce it, you can simply call it as equals. So x equals to A3 of mod M3, x equals to A4 of mod M4, because we are taking k equals to 4. So now what I need to do, our goal is to find integers w1, w2, w3, w4. These 4 are such integers. So we need to find this solution for these integers, right? So how we are going to? So first of all, you need to construct the table, and for the value of mod M1, for the value of mod M2, for the value of mod M3, for the value of mod M4 with respect to the W1 values. So W1 equals to value of mod M1 is 1 and the value of mod M2 is 0 and mod 3 is 0 and M4 is 0. So only for W1 M1, so you can have the value 1, and similarly W2 M2 you can have the solution 1 and remaining are all said to be 0. And similarly W3 mod M3 is said to be 1 and remaining are said to be 0. And W4 and M4 is said to be 1 and remaining are all said to be 0. Right. So once we have found W1, W2, W3, W4, so it is easy to construct X value. So X value, so to find the unique solution X value, it is easy. It is very easy. So what we need to find the solution actually, X equals to A1 W1 plus A2 W2 plus A3 W3 plus A4 W4. This is the unique solution. This is the unique solution. We need to find out the values and substitute all those values in this formula. So X is called as a unique solution for all the A1 and W1 or A2 W2 A3 W3 A4 W4 congruences, simultaneous congruences. So X is the unique solution for all these A1 W1 A2 W2 A3 W3 A4 W4 simultaneous congruences, right? So now how can we substitute and how can we find the W1 values? We'll see in the session. So moreover, as long as the module M1, M2, M3, M4 remain the same, we can use the W1, W2, W3, W4 with any of A1, A2, A3, A4, right? So to find this, to obtain this X equals to A1, W1 plus A2, W2 value, first of all, we need to define three ways. So in that, first we need to define Z1 values. Z values, that means Z1, Z2 and Z3, Z4. So first we need to define them. So Z1 equals to M by M1. So M by M1. So M is nothing but we can write M1 dot M2 dot M3 dot M4. Here k equals to 4, so that you can write up to 4. If k equals to 5, you can write up to M dot M5. Up to 5 you need to write. So here k equals to 4 in the sense you can write up to 4 only. So Z1 equals to M by M1 is nothing but M2 into M3 into M4. Similarly Z2 find out. Z2 equals to M by M2 equals to M1 into M3 into M4. And similarly Z3 equals to M by M3, that equals to M1 into M2 into M4. And Z4 equals to M by M4. M by M4 is nothing but M1 into M2 into M3. So now we got the solution of Z1, Z2, Z3, Z4 values. Right. Now we got it this and there. Next we need to find out what Y1, Y2, Y3, Y4 values. We need to find out based on this Z1, Z2, Z3, Z4 values. We need to find out Y1, Y2, Y3, Y4 values. Because we are having the k equals to 4, right? So to obtain this Y1 values, Y2 values, Y3 values, what is the value? Z1 universe. So Z1 universe of mod M1 and Z2 universe of mod M2 and Z3 universe of mod M3 and Z4 universe mod M4. Right? So to obtain this Y1, Y2, Y3, Y4 values, we can have this formula Z1 inverse of mod M1, Z2 inverse of mod M2, Z3 inverse of mod M3 and Z4 inverse of mod M4. So we have to define these Y1, Y2, Y3, Y4 values. So now first we define Z1 values. After that we define Y1, Y2, Y3, Y4 values. And next lastly what we have to do? Lastly we have to define W1 values. Lastly we have to define W1, W2, W3, W4 values. So how? W1 equals to Y1 Z1 of mod M. Y1 Z1 of mod M and W2 equals to Y2 Z2 of mod M and W3 equals to Y3 Z3 of mod M and W4 equals to Y4 Z4 of mod M. Right. So this is the way you can find these values W1, W2, W3, W1, W3, W. So W1, W2, W3, W4 values you need to find. So Y1 values we got it, and Z1 values we got it. Now we need to find out W1 values, W1, W2, W3, W4 values. So how? W1 equals to Y1 we know already, Z1 also we know, and now Y1 into Z1 of mod M. M values also we know, so M equals to what? M1, M2, M3, M4. This is the value of M, right? So we know the Y1 we know, Z1 we know, and find the W1 equals to Y1 Z1 of mod M. Similarly, W2 equals to Y2 Z2 of mod M. Similarly, W3 equals to Y3 Z3 of mod M. And W4 equals to Y4 Z4 of mod M. So finally, we got it all the W1, W2, W3, W4 values. W1, W2, W3, W4 values. We got it. So now we have the solution is what? X equals to A1 W1 plus A2 W2 plus A3 W3 plus A4 W4. So substitute all these W1 values in A1 W1 or A2 W2 or A3 W3. So that you'll get the solution X equals to final solution X equal to A1 W1, A2 W2, A3 W3 plus A4 W4 value. So this is the unique solution. This is the unique solution for all these values. So this is the unique solution you need to obtain. So you need to obtain from Z1 values or from Y1 values, right? So here one thing we need to remind that whenever you are going to find the Y values and Z values is simply, so you can have the M value so that you will get M1 value, M2 value, M3 value as per that scenario. But for Y1, you need to find the modulus of the numbers. You need to find the modulus of the numbers based on this two. Here you can see the universe exists by second, and we can find them by Euclid's extended algorithm. Euclid's extended algorithms. So here we need to keep that Y1 Z1 to be one mod of M1. Y1 Z1 to be one mod of M1. So we should maintain this as a rule. We should maintain this as a rule. So Y1 Z1 equals to one mod of M1. Then you can find the Y1 values clearly. So you need to find the modulus of these numbers. With the help of these numbers only, you will get the Y1, Y2, Y3, Y4 values, right? So after finding this Y1 values, after finding this Z1 values, you can substitute the Y1, Z1 values into this W1, W2, W3, W4 values. So W1 value is nothing but Y1, Z1 of mod M, and W2 is nothing but Y2, Z2 of mod M, and W3 is nothing but Y2, Z3 of mod M3. So W4 is nothing but Y4, Z4 of mod M. So this is the way you can obtain the solution X equals to A1 or W1 plus this one, right? So here you will have this problem like X equals to some values, X equal to some values. Then you can find the W1 values with the help of Y1, Z1 values. So once you got it Z1 values, then Y1 values, then you can write W1 form. Right. Now you can see one example. So as per this statement, as per this theorem, so we can see some congruences, simultaneous congruences. Here X equals to 6 of mod 11, X equals to 13 of mod 16. So that is not equal symbol, that is a congruent symbol. So if you are not able to pronounce it, you can pronounce it as a equal. Okay. So X equals to 6 of mod 11, X congruent to 13 of mod 16, X congruent to 9 of mod 21, X congruent to 19 of mod 25. Right. Now they given this A values and M values. Right. So here you can see since 11, 16, 21, 25, those are M values. That is nothing but M1 value 11, M2 value 16, M3 value 21, and M4 value 25. Right. So now with the help of this M1, M2, M3, M4, you can find the m value. M equals to m1 dot m2 dot m3 dot m4. A dot indicates star operator. So you can multiply all these congruences. So m1, m2, m3, m4. So what is the value you'll get? So 11 into 16 into 21 into 25 is equals to 92,400. 92,400 you will get. So that is nothing but m value. So m value you can find it. So now m value is obtained, and here, so what is the k value? So k equals to 4, because we can have this is 1, this is 2, this is 3, and this is 4, right? So k equals to 4. Now you got it. M1 values you know, M2 value you know, M3 value, M4 value. With the help of them, you can see A1 value 6. As per the theorem, x equals to A mod M. So that we know A equals to 6. So A1 equals to 6, A2 equals to 13, A3 equals to 9, and A4 equals to 19. A4 equals to 19. So now we know that M value, M equals to M1, M2, M3, M4, that is 92,400. And we know that A1, A2, A3, A4 values also, right? So we know that M values and A values to obtain the solution. So how to obtain the solution? We should compare first of all Z values. As per this previous, we know that first of all we define Z values. So first of all we need to find Z values. So Z1 equals to what? M by M1. That is nothing but M2, M3, M4. Indirectly you can multiply M2, M3, M4, or else you can divide M by M1. You can divide M by M1. So that you will get what? 16 into 21 into 25 is equals to 8,400 value. Right? And similarly Z2 value you can find M by M2. So M by M2 is nothing but indirectly M1 into M3 into M4. So that 11 into 21 into 25, that is equal to 5775. And similarly Z3, that equals to M by M3. So M by M3 is nothing but indirectly M1 into M2 into M4, that is nothing but 11 into 16 into 25, 4400. So Z4 same. Z4 is also M by M4. So M by M4 is nothing but indirectly M1 into M2 into M3. So the value is 3696, right? 3696, right? Okay. Now we obtain that Z values, right? Z1 values, Z2, Z3, Z4 values, we got it. Now what we need to do again, we define Y1 values. So Y1 values we need to find. Y1 values we need to find. So look at here. So Y1 equals to, what is the formula? Z1 inverse of mod M1. So Z1 value is what? 8,400 inverse. 8,400 inverse of mod 11. 8,400 inverse of mod 11. So you can write like this statement. You can write like this statement. So 8,400 inverse of 11, mod 11. So that is nothing but congruence to 8,400 divided by, you can divide 8,400 divided by modulus 11. So what you will get? 11, 7, 77, and here we will get 7, 0, 0, 7, 0, 0, and similarly 11, 6, 66. So if you put zeros, 66, and if you are here you will find what? 40, right? You will find 40. So this is the way you can find, the values. So the 8,400 mod inverse of mod 11 equals to 7, right? So the remainder you will get 7. And similarly for the 16, 5775, 5775 divided by 16, what you will get? 16 3 are 48, 16 3 are 48, and 57 minus 48 is nothing but 9, 97, 16 8 are 16 5 are 80, 16 6 are 96, right? 16 6 are 96. Then you will get 1 and 5. So the 15 is remainder. So like the way you will get. So like the way you will get all the values. And 4,400 inverse also. So 4,400 divided by 11. So 11 3 is 33. 11 3 is 33. And 70, 11 6 is 66. and 4 0 11 3 is 33, and the remainder is sorry 21. Sorry 21. So you should divide 4400 with 21. So that what you will get, 21 into 2, 42. So 20. I will explain. See here. So mod 21. So 21 4400. 21 4400. So 21 2 is a 42. So here 2 0. So 2 0 is the remainder, and again 0. So 21 like 9. 21 9 is 9 1 is 9, 9 2 is 8. So the remainder is what? 11. So 11 you will get here. So same 15 here you will get, and here also 7 you will get. So the reminders you will get here. Right. Similarly for the 3696 also. 3696 also. So 3696 divided by 25. 3696 divided by 25. So 25 1 is 25, and here 19 on the 6. So 25 7 is 175. Here you will get 21. So 21 as a node. So this is the values you will get here. After finding these values, again what you need to do? So you need to find these values. Find these modules values. So what you will get here? 11 into y1 equals to, you will get the mod 7 into y1 equals to mod 11. 7 into y1 equals to mod 11. So 1 mod 11. So how you will get the values? Y1 you will get 8, and y2 you will get 15, and y3 you will get 2, and y4 you will get 6. The values you will get here by doing the modulus operations. By doing this modulus operations for the y1, for the y2, for the y3, y4, you will get this all the values 8, 15, 2, 6. Right. So after finding this all the values, you will say y1 equals to 8 mod 11, and y2 equals to 15 of mod 16, and y3 equals to 2 mod 21, and y4 equals to 6 mod 25. Right. So this is the way you will get all the y1, y2, y3, y4 values. After finding this y1, y2, y3, y4 values, so you have obtained this both y1 values and z1 values, right? So now what you need to do? You need to find the w1 values. You need to find w1 values. So how will you get? So w1 equals to y1 z1 of mod m. y1 z1 of mod m. So y1 is nothing but 8. So y1 is nothing but 8, and z1 is nothing but 8400 into of mod m is nothing but 92,400. So 8 into 8,400 into mod 92,400. That is nothing but 67,200 of mod 92,000. Right. Similarly, W2 also you need to find y2 z2 of mod m. y2 z2. y2 is what? 15 of mod 15. Only 15. You need to say that y2. And y3 is what? So y3 is 2, and y4 is what? 6. So substitute this y1, y2, y3, y4 values in w1, w2, w3, w4 formulas, so that you will obtain the solution for the w1. You will obtain the w1 value, w2 value, w3 value, and w4 values. You have obtained all the values. After obtaining all the values, what you need to do? We already said that we have a unique solution x equals to a1 w1 plus a2 w2 plus a3 w3 plus a4 w4. That is depending upon k equals to 1 or 2 or 3 or 4 values, right? So substitute all those w1 values in this unique solution. X equals to a1 w1 plus a2 w2 plus a3 w3 plus a4 w4 of mod m value. So substitute them. Then that is the unique solution for this all the congruencies. After substituting this obtained solution, you can say that this is the solution for all the simultaneous congruencies. Right. So this is the way you can find the simultaneous congruencies. So first of all, you need to find m value with the help of m1, m2, m3 based on the given k equals to 4 or 3 or something. So after obtaining that m value, so you should find first of all z1 values. So after finding the z1 values like m by m1, m by m2 with the help of them, so z1, z2, z3, z4 you will find. After finding that z values, you are going to find y values. So after finding y values, you are going to find w1 values, w1, w2, w3, w4 values, right? So the formulas here, you can see that formulas and you can substitute all your values in these formulas. So after substituting the values in these formulas, you can have this obtained solution. X equals to a1 w1 plus a2 w2 plus a3 w3 plus a4 w4. So this is the values you will get. So here one thing we should know about. So in the previous this one, so where Euclidean extended algorithm says that what if a and b are positive integers, what it does is actually extended Euclidean algorithm says if a and b are positive integers, then there are always integers m and n, so that the GCD of a and b is equals to a and b is equals to m dot a plus n dot b. So that is what we mentioned here. So this formula is for to finding the congruences when it is becomes GCD of a comma b or else y comma z equals to 1. So there you can obtain this. It allows the computation of multiplicative inverse mod b. So multiplicative inverse, for this multiplicative inverse you can see here. So for this multiplicative inverse only you will find here. So for this purpose you can see this extended Euclidean algorithm. So since the suppose we will take the example 210 and 45. So the GCD of 210 and 45 is what? 15. So we should be able to write 15 as a sum of multiples of 2, 10 and 45. So we should write multiples of 15 to this 2, 10 and 45. So here how I will do it? So divided by 210 by 45. So you can write 210 equal to 4 into 45 plus 30. Yes, obviously you can write. Again, 30 is also you can write like 1.410 minus 4 into 45. Yes, obviously you can write. So divided 45 by 30 and get the result is 1. So 30 by 40 and with the remainder 15. So remainder is what? 15. So 45 equals to what? You can write 1 into 30 plus 15. 1 into 30 plus 15 you can write. So after writing this one, 15 equals to what? 45 minus 1 into 30. 45 minus 1 into 30 you can write. So 45 minus 1 into, instead of 30, you can write what? 1 into 210 minus 4 into 45. This is what you have to write. So 45 minus 1 into 30. Instead of 30, you are going to write 1 into 210 minus 4 into 45. You should write. Okay. Then what is the value? So minus 1 into 210 plus this 45 and this 4 into 45 is becomes 5 into 45, right? So 445 plus 45 is nothing but 5 into 45. So this is the obtained solution. And these are all the sums of multiples. You can say that sum of multiples for 15. Sums of multiples of 15. You can say that. So why we are saying this means to obtain a congruent solution here, we can remember this one. We can remember this formula. For prime integers. Okay. So coming to this problem. So after finding all these z1 values, w1 values, and y1 values, simply you can substitute in the unique solution formula. So that is x equals to a1 plus a2 plus a1 w1 plus a2 w2 plus a3 w3 plus a4 w4 of mod m value. So there you can substitute all these w1, w2, w3, w4 values. Then you will get the unique solution. That means you have to write the unique solution for this simultaneous congruences, all these congruences, right? So this is the way you can identify, this is the way you can find the congruences or find the unique solution. So here they given congruences, but you can find the unique solution. But in some cases they will give the unique solution. You need to find the different solutions, different congruences, right? So we'll see another example here. So find all solutions. Find all solutions for the x square congruence to 1 mod of 144. 1 mod of 144. This is the problem they given. So here find all solutions. So in this example, we have the simultaneous congruences. We need to find the unique solution. But here they given a solution. They given a unique solution. We need to find the different solutions of this congruence, right? So how, we'll see. So first of all, x square equals to 1 mod of 44. 1 mod of 144. So that is the complex number 144. So you can simplify them. 144, you need to simplify that 16 into 19. 16 into 19. So that you can simplify that solution. So x square, so 144 equals to 16 into 4, 16 into 9. So that you can write 2 power 4 into 3 square. Right, yes, so 2 power 4 into 3 square. And the GCD of 16 comma 9 is also 1. 16 comma 9 is also 1. So now we can replace our congruence by two simultaneous congruences. So how? X square equals to 1 mod of 16 and x square equals to 1 mod of 9. So this is the way you can write as for to obtain the simple solution. To obtain the simple solution, right? Okay. So now you can see here x square equals to 1 mod of 16, x square equals to 1 mod of 9. It has a 4 solutions. It has a 4 solutions because 16 equals 2 power 4. So that we can say that it has a 4 solutions. So means we need to obtain 4 solutions. Similarly, 9 for the 9 3 square. So this is the 2 solutions. For this 4 solution, this is for this 2 solutions. So you can write like this: x square equals to 1 mod of 16 has 4 solutions. X square equals to 1 mod of 9 has 2 solutions. That 4 solutions are like what? X equals to plus or minus 1 or plus or minus 7 of mod 6. Plus or minus 1 or plus or minus 7 of mod 6. Here 7 will get like if you divide 9 with 16, if you divide 16 with 9, you will get the remainder is what? 7. So the 9 1 9, so 7 is the remainder. So you can obtain the solutions 1 plus or minus 1 or plus or minus 7. Plus or minus 1 or plus or minus 7. So this is the way you can write here. X equals to plus or minus 1 or plus or minus 7 of mod 6. Similarly, x square congruence to 1 mod of 9 has 2 solutions. So that is nothing but x equals to plus or minus 1 of mod 9. You can write plus or minus 1 of mod 9 you can write. So with these 2 solutions, you can write the total number of alternatives. You can write 8 alternatives. With the help of this, x equals to plus or minus 1 or plus or minus 7 of mod 16 and plus or minus 1 of mod 9. With the help of these 2 solutions, we can have different types of alternatives. We can have different types of alternatives. So write them. So x equals to plus or minus indicates one time plus and one time minus, right? So obviously you will get x equals to 1 mod of 16 one time and x equals to 1 mod of 9 one time, right? Now this first alternative is clear. And for the second alternative, so x equals to 1 mod of 16 and x equals to minus 1 mod of 9. Is that clear for the second one, right? And next third one, x equals to minus 1 mod of 16, minus 1 mod of 16 and x equals to 1 mod of 9. So this is the positive side. And similarly, x equals to minus 1 mod of 16, x equals to minus 1 mod of 16 and x equals to minus 1 mod of 9. Similarly, now with 1, x equals to plus or minus 1, with mod 9 is over. Now with 7, you will see. So x equal to 7 mod of 16 and x equals to 1 mod of 9 is one solution. And x equals to 7 mod of 16 and x equals to minus 1 mod of 9 is another solution. Similarly for the minus 7. So x equals to minus 7 of mod 16 and x equals to 1 mod of 9, one solution. And x equals to minus 7 of mod of 16 and x equals to minus 1 mod of 9 is another solution. So like the way you can find all these alternatives, after finding these other alternatives, you can see here k equals to what? You can say k equals to 2 solutions we have, because x square equals to, so k equals to 2. Or else you can say here also x square equals to 1 mod of 16, one solution, and x square equals to 1 mod of 9 is another solution. So total k equals to 2. So with the help of k, and m1 equals to what? 16, and m2 equals to what? 9. So that is nothing but this form. So you can write k equals to 2, m1 equals to 16, and m2 equals to 9. So in this case, the above has unique solution for x modulo 144. That is what we known here. So we have unique solution x modulo 144. We need to find the different solutions for this x modulo 144. So now we need to compute what? First of all, we need to define z1 value. So z1 equals to what? M by m1. So m by m1 is nothing but m2. So m2 is nothing but 9 here. Similarly, z2. We need to find out z2 value, z1 value, and we need to find out y1 value, y2 value. After finding this z1, z2 values, what you need to do? We need to substitute in the w1. To find the w1 values. So w1 equals to y1 z1. So here y1 is where? y1 is 9, and the z1 y1 z1 of mod. So z1 is 9. So 81 of mod 144. And y2 also 16 inverse. That is nothing but, so 4 of mod 9. So w2 is nothing but y2 z2. So y2 is nothing but 16. Z2 is nothing but 16. And y2 is nothing but 4. So y2 z2 of mod m. So mod m is nothing but 144. So now we compute z1 and y1 and w1. Similarly, z2 and y2 and w2. So we found all these z1, w1, y1 values, and we substitute into the solutions. So x equals to, so plus or minus 1. So 1 into, the solution is what? 1 into 81 plus 1 into 64. 1 into 81, this is the value, and 1 into 64, this is the value, right? So 1 into 81 plus 1 into 64, that equals to 145. That is nothing but 1 mod of 44. Similarly, 1 into x equals to 1 into 81 plus of minus 1 into 64. So we need to substitute these values in all these values. So all these values, if you substitute all the values, so you will get the final solutions. So x equal to 1 into 81 plus or minus 1 into 64. Similarly, x equals to minus 1 into 81 plus 1 into 64. You will get this value. So like the way you will get all these values for all solutions. So like the way you will get all the values for all the solutions. So this is the way you can find the values, find the solutions for the unique values. Means they will give simultaneous congruences. You will find the unique solution. Unique solution is what here, and they will give unique solution. And for this you can find different possibility solutions. That is nothing but congruences. You can say that. So like the way you can find all these congruences, or else you can find the solution. You can find the obtained solution. So initially we need to know about what. So we need to remember that a1 values and m values, m1, m2, m3, m4 values. So based on that values, we'll have to find z1 value. So z1 value and y1 values, and then w1 values, right? So after finding z1 values, y1 values, w1 values, we have the unique solution is what? X equals to a1 w1 plus a2 w2 plus a3 w3 plus a4 w4. So in that formula, you can substitute all that obtained solutions, obtained values in this formula. Then you can say that it is having unique solution for these congruences. You can say that unique solutions for these congruences. So this is one type of problem. So they will give simultaneous congruences. So with the help of that simultaneous congruences, you need to obtain a unique solution. This is one scenario question, and the other scenario is what? So they will give the solutions. They will give the solutions. So with that, you can say that different possibilities, different simultaneous congruences you can find. Right. So giving the simultaneous congruences and finding the solution, unique solution, and giving the unique solution and find the different possibility solutions, different congruences is another way. So this is the way you can find, and this Chinese remainder theory is completely based on simultaneous congruences concepts and along with the modulus concept, right? So modulus concept and the congruences both are committed together. Then they will find each and every values for the solutions, right? Okay. So thank you all. Thanks for the watching.
Like, share and subscribe. Hit the bell icon for more updates.